On stage, I will have the pleasure to call José Roberto Ferro to be here with me on stage for the activity about lean transformation, configure to order business model in TechnipFMC. Okay, so Ferro, I will leave you here on stage.
Pleasure to be here. Pleasure to finally, this ship is real. Now I see, I was seeing only in my screen. Now I am on board. Good to be on board. And it's my pleasure to introduce our next speaker, which will be Carolina Cruz. She will be speaking from Malaysia, and she will explain a very fascinating story that's unfolding in the oil and gas industry. TechnipFMC, the company that Carolina works, she has been leading a substantial revolutionary transformation in their business model. From a traditional, in this industry, engineer-to-order business system, business model, to a configure-to-order model. So, Carolina, a pleasure to be with us, and it's an honor to have you sharing with us your story. Please.
Thank you, José Ferro. It's a pleasure to be here participating in this event. So thanks for inviting me and giving me the opportunity to share our learnings through our transformation to the configure to order business model. So thank you. So we'll start sharing a video so that everyone can learn a bit more of the business we operate. We work in the oil and gas industry, so we're responsible for supplying solutions for the oil and gas industry. I'll share a video that tells a bit about what we do and the start of our transformation with our new product platform. Okay, so this video is just to share a bit of what we do. Our industry, our business operate mainly subsea. We have surface business that we operate in the oil and gas, but this transformation happened in our subsea business, where basically you see a lot of products. They're quite big, heavy, like we're talking about some equipments with 50 tons some 200 tons. So it's a very complex technology involved, a lot of engineering required to ensure we have solutions that can allow us to produce oil subsea. So that's, I think, trying to simplify a bit of our complex environment where we operate in this industry. So we are a market leader in this business, and we started our journey around 2015, 16, when we started to see some problems in the market, right? So we started to look at the oil price decrease, and that started to create a challenge in the business, right? So the operators couldn't make some of their projects economically viable because of the challenges with the oil price. And we, as suppliers in this business, had to reinvent our products and our solutions to support the operators to make those projects viable. So we had to find ways to reduce the operational costs for the operators to make more projects possible in this business. So that's when we started to develop Subsea 2.0, where basically we had the vision to return the economics on the subsea projects by reducing 50% on the product weight, size, and part count. So when we look at the our main product is called a Christmas tree. So the tree is responsible for producing oil from the well subsea. Basically, we our traditional legacy product had like 50, 70 ton weight, 7 meters height, very very big and heavy equipment. So we target ourselves to reduce that by 50%. And also when it comes to part count, we had several small parts on the product, so more than thousands. So we also target ourselves to reduce the amount of parts and components to really make our products leaner, simpler, better to build, and more standard, with the ambition to reduce product lead time. So our new portfolio is called Subsea 2.0. So it's comprised of the main products we have subsea that are needed to create the infrastructure to produce oil for the operators. We launched our new product in 2017, end of 2017. But as we launched that problem, we still had a big problem to solve. So basically, in the past, our traditional way of operating and designing and producing all these products to our clients were by using the engineer to order model. So all the design, qualifications, preparations for the product, and also for manufacturing and our supply chain was something done during the project lead time from our clients. So we would get an order with some requirements that they needed, and we would start designing that product and designing the entire process to produce that product during the project lead time. So uh, the way the engineering business model operates was setting some limitations to leverage this new platform that we launched to the market. So we were trying to reduce costs, lead time, and also increase our quality assurance. But the way we were operating was still driving a lot of variety. So engineering to order, since everything is possible because you're designing during the execution, you have some challenge to control variety, right? So you still have a lot of uncertainties and things that could be added to your product during the execution phase. So we were facing a lot of challenges, so we couldn't reduce cost anytime. So that was still driving cost anytime to a bit longer. Execution and quality risks is still high. And as we was understanding and trying to leverage our new platform, we also concluded that a make to stock solution wouldn't exactly bring us to the value to the client that they need, because a make to stock would require defining a standard product without giving any flexibility to the client. And all the different fields subsea, they have some different challenges. It's not everything the same, so depending on the water depth and some temperature and pressure from the well, it will require a different solution from a technical perspective. So we had to allow some flexibility, but not as much flexibility as we would normally allow with engineering to order model. So we started to do a lot of analysis, and that's when we started to use all the LPPD methodology by doing some value streams and really understanding how we operate and how we can leverage our new product platform to simplify the execution and transform our business. So, as we started that investigation, we concluded that we needed a fundamental change in how we operate, and that change was towards transforming our business model from engineering to order to configure to order. So that was a big change for our company, because it changed not only processes and product, but also how people do the work, also some of the culture, because the way you drive things in one model, the mindset required is completely different from the mindset in the other product. And also how we work with clients, how we engage with the client, because configure to order allow you to have flexibility, but it's not infinite amount of flexibility, right? So there are some boundaries, and defining those boundaries to allow you to really get the benefit of this model requires a lot of work with the client. So that was an extremely important factor in our journey in our own development. So our transition towards CTO was possible because Subsea 2.0, our new product platform, was a platform designed with the ambition of having a pre-engineered architecture enabling the configuration at the assembly level. So in our legacy product, since we were operating in an engineering toward the environment, it was okay to change the product and design new features and change even the product architecture project by project. When we started to develop Subsea 2.0, along with the targets to reduce part count, size, and weight, and lead time, we also challenge ourselves, especially when it comes to lead time, what we could do different. How could we remove engineering from the execution? So we challenge ourselves during the design and the creation of this new architecture with pre-engineered components and configurations was a key enabler to our transformation from ETO to CTO. So basically, the value proposition was configurable product. So you don't have engineering happening for every single project. You just select from your catalog and build your product based on the pre-engineered components. That in turn reduce cost, lead time, and allow us to leverage standardization, and that in turn end up leading to more predictable deliveries, execution, less quality escape. So that was a big change when we compare to an engineering to order model, where you have a lot of risks, and you always get some surprises and things during the execution that threat your delivery schedule. During our transformation, so as I said, we launched the product in 2017. So beginning of 2018 is when we started to transform our business model. So it has been a long journey, and the key enabler for our transformation was really the connection between product and process. So the LPPD methodology, and not only the tools, but the way of thinking the problem, the way of approaching the problem, the way of engaging people were fundamental to allow us to really transform the way we operate. So we started assigning a chief engineer to this problem. So I was the one selected to lead this transformation to CTO. So the sponsor recognized that we had to do something. We launched this great platform, but we that wasn't enough to give us to allow us to offer the value proposition to the client that we could do with this platform. So he had recognized that. He assigned the chief engineer to the problem. So I gathered the team. We started to understand what were the challenges that we had with the existing model that were preventing us from leveraging the product platform. So we defined the vision, the milestones, the target. We aligned that with the sponsor and also the key stakeholders that needed to support this transformation. Um, During the initial phase, our investigation was key, but having a well-structured concept paper and also working A3s to really understand the problem, look at the data from the current state, and define a way to have your actions and do a PDCA, and check if the actions are really addressing the problems you identified in your left side of the tree were extremely important. So we were in the beginning um, trying to connect both A3 and concept paper because they were complementary in a way that they allow us to really understand the situation and really create a good case and plan for the team to engage and start working with us towards this transformation. So having an OBEA and, as a matter of fact, an operating system and management system in place where we had a cadence with the team, we had a cadence with the sponsors, and a clear help chain and clear milestones defined was also fundamental to keep the pace. So it was a big change for our company, a global change. It impacted all our business in Americas, South America and Brazil, US, Europe, and also here in Asia. So it was like a company worldwide transformation. So we had to engage people from different locations. So having a good management system in place to ensure everyone is connected, everyone understands what is the main objective. We have clear deliverables, and we can differentiate normal from abnormal, and as for help when needed, was extremely important to keep the pace. Was extremely challenged as well because as we were learning by doing, sometimes we struggle a bit to really differentiate normal from abnormal. So that was a big challenge for us in the beginning to really get everyone aligned on the understanding and expectations on the quality of event criteria for the milestones to allow us to really understand what is good and what needs to improve. But as we progress, we started to create a good dynamic and good cadence and get the team aligned and focus on the transformation. We also used a pool system to ensure we will not delay the project. So we had milestones pooling what were the deliverables required to achieve the main goal. And we used to de-risk the execution, de-risk the development. We use a set-based concurrent engineering approach where we run multiple solutions in parallel as we were developing the product, because it was at some points during the investigation we had alternatives to a specific problem that choosing just one option could eventually end up in a situation where we would go that far with that option and conclude that maybe it's not giving exactly what we need, it's not really solving the problem. So in order to really de-risk our development, we use this set-based concurrent engineering methodology, and that was quite helpful in many of the challenges that we had to overcome as a team. We use a lot of trade-off curves. So during this set-based concurrent engineering process, as we had multiple solutions, we had to make sure we were making the right choice. So using data-driven decisions based on the trade-off curves, and also information from the prototypes that we did were extremely important to drive us towards the right solution. So a lot of the things we work on the concept phase in 2018 and 2019 were the things that we actually using now, and the deselection process was very helpful. It took some time to get everything aligned and identify all the options in the beginning. So the plan was really something that we put a lot of effort, but then it helped us accelerate the process and the development of the program after that. Last but not least, I mean, all those steps were worked toward throughout the entire development, and they kind of connect each other. But the notion of value stream readiness was extremely important for us. So we didn't use that since the beginning of the development. It was more or less in the middle of the development that we started to use this metric, and that was extremely important to get all the functions aligned. So we started to see that some functions were far ahead compared to others when it comes to the development, and that was creating some problems to get us to the end of the line. So we started to use this methodology. We define what good looks like for all the levels of maturity, and that helped get everyone progressing at the same page, because ultimately if you get one function to go too far, that may create a problem to the one that is lagging. So we created that notion of having everyone collaborating and progressing together, and that was extremely helpful to address some of the challenges we identified during the development. So with that, we had the results, right? So the CTO results were basically, we managed to eliminate engineering. So based on the changes required from engineering to order to configure to order, so we had to come up with a way to eliminate engineering from the execution phase. So make sure that everything is really coming from the catalog. We have a robust catalog that meets the market, that meets what are the functionalities that our client needs. So working on that was one of the objectives. Redefining our supply chain strategy, make sure that the way we source and procure material, it's aligned with the new platform. It's not like on a project by project basis. We're no longer buying one-off component. We basically buying and leveraging standard components. So redefining our sourcing strategy was extremely important, and also the transformation of our manufacturing flow. So we had a different product architecture, a configurable product architecture that allow us to leverage a lot of the process that we would normally do for each and every project. So we managed to standardize a lot of the way we do things, and we managed to create a dedicated and specific flow for this new product here in our plant in Malaysia, that allow us to further improve our execution. So we still have, for some specific needs, the legacy product being offered in the market, but that was creating some challenges for us to leverage the benefits of this 2.0 platform in the manufacturing. So we created this manufacturing line in Malaysia that allow us to really flow the product, leveraging the most of the benefits from its platform. So the results were, from engineering, it was easy to see in one of the products we have in the subsea field, 20 plus out 1,000 hours of engineering to design one product. So we managed to eliminate that and really leverage our configurator to create the products for our subsea solutions. That in turn resulted in a reduction of 6 months lead time at the minimum, right? Because depending on the solution, it would require qualifications and it would be even more than 6 months. But in average, considering like some standard solutions or very kind of stable solutions that we had in the past, but was still engineered to order, we managed to reduce 6 months lead time by just leveraging our configurable platform, connecting with our clients, and make sure we have a solution that is meeting the market needs. Redefining our sourcing strategy for CTO allow us to remove a lot of inventory that we had with the previous business model. So because of all the risks associated with engineering to order, we would normally use a stocking strategy to try to mitigate some of the risks. With Subsea 2.0 and CTO, we managed to remove inventory and also reduce quite a lot our lead time because we worked with our suppliers to leverage the standard components, and in turn they managed to streamline also the processes and things that would require approval of procedures and way of doing manufacturing that allow us to reduce 8 months of the lead time from our supply chain. And last but not least, when it comes to manufacturing, by developing a dedicated manufacturing line for this product, we increase our throughput by 2.5 times compared to the legacy platform. We're using the exact same infrastructure, so that allows us to deliver more without having to invest the same amount we would invest if we were to sell the legacy platform. So that was a great improvement to meet the growth that we see now in the market. So for the client, we offering now lower cost and shorter lead time. Shorter lead time for them also connect to lower cost because ultimately, if they start producing oil faster, they get returned faster. So that helps with the economics of the project. So that is in 30 minutes or a bit less than that, the short story of our transformation. As I said, it started in 2016 with the development of our product. The transformation of the model started in 2018, and here we are in operating mode. So basically, we're now executing this model already, and we are working towards the improvement and continuous improvement phase of our model. So that's me. Thank you.
Thank you so much for sharing this story. I think it's a fantastic ongoing story because, as you said, it requires a transformation in the whole company, not only the product designs, but everything the company does. Sourcing strategy, manufacturing flow, all the support functions, planning, quality control, finance, costing, and everything. So it's great that you were able to share your experience, your story, and this is to be continued. This is just, it took a long time, it takes a long time, it's very complex, but to be continued. Thank you so much for your sharing. Thank you.
Thank
Christopher.
you for the opportunity.
Thank you. Thank you, Carolina. Thank you, Ferro.